Okay, question 2. Every Friday, the same number of workers from a large office building regularly purchase their lunch at 2 locations, the deli or the cafe. And it has been found that on those who purchase their lunch at the deli, 65% will return to the deli. And those who get it at the cafe, 55% will return the cafe. So they want a transition matrix. And so we could just quickly set it up ourselves. Now, looking down there, they're saying DC, so we'll do DC. And here it says, the first one, it says 65 from the deli to the deli. So we change that to a decimal, 0.65. And then they said 55 from cafe to cafe, so 0.55. Now, remember, they have to add up to 1. So that makes this one 0.35 and this one 0.45. So we're looking for that one, which looks like D. Okay, so this is just a transition to help you understand. So there's a yoga class at the gym, and you either go from a morning, a lunchtime, or an evening. Now, they said, for example, if there was 30 people at the morning, so you begin at morning, they're saying that you would, if you look at morning, so 60% go back to morning. So if there was 30 begin with, 60% of 30, 18 are going to go back to a morning session. And then if we look at 10% are going from morning to lunchtime, so 10% of the 30 people, that means 3, and so on. So this is just another example interpreting for you. Okay, a small shopping centre has 2 coffee shops, F and G. The percentage of coffee buyers at each shop changes from day to day using the transition. So the state is a day-to-day state. On a particular Monday, 40% of coffee buyers bought their coffees at Fatima's, or at F. So here they're really helping you set up the initial state matrix. So we know that SO, so we're going to follow the same pattern with F first and G second. And they said 40% are at Fatima's. So I can just keep it as a 40. I'm going to say 40. Now, if 40% of customers are going to F, and they're saying everyone, they all, all the coffees, they're going to go back to the coffee shop, then we're saying 60%, because you've got to add up to 100, must go to the G's on that day. Okay, the matrix recursion relation is used to model. So this is just our normal, meaning that we get the next one by timesing the transition before. So the percentage of coffees you expect to buy their thing on Friday. So they said on Monday. So SO is Monday. Okay, so if you have Monday, Tuesday, Wednesday, Thursday, and Friday, that would be SO, S1, S2, S3, S4. So you want to know what's happening at state 4. So what I'm going to do is I'm going to use the transition. I'm going to use the nth term formula, and I'm going to go S to the power of 4 times SO. So into the calculator, I'd be putting this transition, and I'm going to raise it to the power of 4 and times it by my initial scenario, which was 40% and 60%. I left it as a whole number because it's written in a whole percentage, so I'll leave it like that. Okay, and I put that in a calculator and I get 68.1 and 31.9. So if I just round that to whole numbers, I've got 68 and I'm going to say 32. Okay, and that adds to 100%, so that's good. And remember, the top one's F and the bottom one's G. And they said the percentage of coffee buyers who buy their coffee at G on Friday. So S4, remember S4 we worked out was Friday. So G, that would be the 32B. Okay, here they want you just to set this diagram into a transition. So we've got 3 states, so we're going to have a 3 by 3. And I just looked down to see what they're doing. They're doing HTC, so I'll do HTC as well. And I'm going to start here, and then I would end here. And remember, it's easy to do the ones going back to themselves. So H to H was 0.3. C to C was 60, so C to C was 0.6, and T to T was 50, so 0.50. Now if I do the other ones, I'm going to just do all the H ones. So H to T, so H to T was 0.4, oops, I can't read that now, 45, and H to C was 25. So hopefully they all add up. Now C to H, so C to H was 0.4. So that's already, if I look at this column's already adding up to 1, so this should hopefully be a 0. So I should see no C to T, which I don't, so that's good. And the last one, if I'm at T and I go to C, it's 20%. So at the moment I'm up to 70 in this column, so I want T to H to be 30, which it is, so 0.3. So we're looking at that because they all add up to 1 now. So we're looking for that answer, which looks like it is B. Okay, Fitness Centre offers 4 different classes, A, B, C and D. The customer's choice is expected to change week to week according to this transition. An equivalent diagram has been constructed below, but not complete. The proportion from one transition is labelled W. What is the value of W? So we want to go where, if you look at the W, is going from something to the other. But we have to work out what's going on here. So let's have a look here. So we've got a 20%. So let's go see if up here we can see a 20%. Now there's a 20% between A and C here. So so we know that if we begin at A, we've got a 20% chance of going to C. So this arrow is going from A, we're going to say to C, okay? And it's also actually going back the other way, because if you're at C, and we said that going back, so we also know that's 20% there too. But let's have a look at what else we've got. We've got a 25% listed here. So I can see 25 listed here. And that is if you start at B, so the B, and you'll go to D. So starting at B and going to D. So that means this is starting at B and going to D. All right, now that I've worked that out, the question wants me to start at A and go to D. So start at A and go to D, that's 0.15, so that's 0.15%. Okay, there's 2 politicians, Rob and Anna. They're the only candidates in the forthcoming election. At the beginning of the election campaign, people were asked who they'd vote for, and the numbers were followed. So this is probably giving us an SO. So we're just going to say Rob and Anna, so 5, 6, 9, 2, and 3, 4, 5, 0. During the election campaign, people are assumed to change using this transition from each week. The total number of people who expected to change the candidate they planned to vote for 1 week after the election campaign is. So if you've got to look at who's changing. So if you're going from Rob and you're going to change to Anna, so 25%, so 25% of Rob's change. And then you've also got the other way, you got Anna and you're going to change to Rob, so you've also got 24% of Anna change. So they want the numbers. So when you say, so we'll work it out, we want 25% of Rob, so I'm going to do 20.25 of Rob's number, which is up there, which is 5692. And then I'm going to do 24% of Anna's numbers, which was 3450. And then I would add them and give the total. Okay, so I've got the total, and if I add those together, I get 2251, which is the answer C. Okay, so here we've got another question, exam question like that one before, where the question is they want to know what this loop is, but we don't know which letter it is. So what we're going to do is we're going to use the ones they've given us. So we look for, I've got a 0.4 here, and I can see it up here in the 0.4. So that's when I go from M to F. So if I'm going from M to F, there's the 0.4. So then if I look at another one, we're looking for, say, we've got a 0.1. So, and it's M, we already know that this one up here is M. So when we go from M to, and look for the 0.1, it's actually going M to T. So we know that's T. And just to double check ourselves, let's check, does from T to M equal 0.2? So T to M is 0.2, so that's good. So we've got all of them, and the only one left is obviously that we haven't written in is L. So the question is asking us for L to L. So if I go from L to L, that's this one. L to L is 0.6, so the answer is 0.6. Okay, Stella completed a multiple choice question that Tessa had 10 questions. Each question had 5 possible answers, ABC. For question 1, Stella chose answer E. Stella chose each of the 9 remaining answers in order following the transition matrix. How did Stella choose, what answer did she choose for question 6? So we're going to go like this. I'm going to write out, she chose for question, so 1, 2, 3, 4, 5, and we want 6. Okay, so we got told what she selected for question 1, it was E. So what you say, that means this question I'm on E, and if you look down E, there's a 1 on C. So that means that's what she picks for the next question. So you go for question 2, she's going to be on C. So now you got to pretend you're on this question. I'm on C. And so you look down and you see, all right, the 1 is on A. So you're now on A. So then we go, all right, we're now on A. Look down and A, well, we're on D. We pick D when we're on A. So there's D. And now we're on D. So you start here and you look down, okay. When you're on D, you pick B. And then for the last one, we're now on B. You look down and we select E again. So which question did she pick? It would be E, and then she'd be back to the start because you're now back at E. But anyway, it was the 6th question. Okay, a water park opens at 9 a.m. till 5 p.m. There are 3 activities: pool, slide, and water jets at the water park. Children have been found to change their activity each half hour as shown in the transition. The group has come to a water park for the whole day. The percentage of these children who are expected to be at the slide at closing time is closest to. Alright, so here we don't know how many kids are there, but we know that that they don't leave. So if we've got to try and think of an initial state. So I'm just going to say, because it says what percentage, so I might put, so we've got pool or whatever, the pool, slide, and water jets. And I'm going to put like a third, or not even, I'll keep it in percentages. I'm going to put just like they split up at the start. So I'll put roughly a third in each percentage. So that adds up to 100%. So I've put a percentage of each. Now, if the park's open from 9 to 5, so that's actually 8 hours, but they say they swap every half hour. So I'm going to say there's 16 swaps because it happens every 13 every 30 minutes, there's a swap. So what I'm going to do, I'm going to say, well, I want to know, because they said at the end of the day. So I'm going to go state 16, that I want state 16, because every half hour they're changing. And I'm going to do this transition here, and I'm going to times it to the power of 16, and I'm going to times it by this what I've created for my SO. So I'll do that. Okay, so I've done on the calculator, and you can see if I round these numbers, because remember this is pool, slide, and water jets or whatever. So we've got 62, I'm going to round that to 14 and 24. So that's what I'm looking at there. But I just assumed that all three went, they just split up evenly at the start of the day. But I can't be sure for that. So what is happening though, if I went and changed the combination, so I went and chucked in 50 in, I changed my initial state, and I said, all right, I'm going to just say with 50% starting at the pool and the other 50% at the slide and none at the water jets. And you can see that I still get the same percentage. And that is, it's not in every scenario, but this is what's happening. And if I, sorry, I'm going to change it. So, and if I did 100, so in this last one, I gave it another go where I put 100 at the pool. So they all started at the pool. You can see even after the end of the day, we still have 62, 14, and 24. So what we're going to learn about this next is that we're going to see that it doesn't, after a certain amount of transitions, you hit a steady state, or what is a long term, which means that it's not going to change no matter how many times we keep multiplying. So you hit what we call a steady state. Now you will learn this, and you would have hopefully known that by the time you got to this question. But we've put it in here just to show you that you can make up an initial state scenario to see what's going on. And we've done that, and then I can't assume that it happened. But when I tested the other ways, I can see that I get the same amount. So you must, by the end of the day, you've hit this long-term steady state. So the question was how many at the slide? Which is the second number, so we're going to say 14%. But don't stress, we'll do steady state in it. So maybe you might just want to write a little note though, that this is a steady state, has been reached by the end of the day. Okay, so with this question, they gave me the initial state and they said the transition. Now they said if you've been given S4 and the transition matrix is this, then S5 is. So you simply can always, if you remember back to the way we get the next state is by doing the transition times the state before. Okay, so that means if I want S5, I use the transition times the state before, which would be S4. But here, they're not giving that scenario. So if you remember back when I said if you want to find the nth term state, remember we do transition to the power of n times SO. But what I said was that these two numbers had to add up to what you wanted. So in this question, I want 5. Now, if you look at all the options, they're saying, all right, they're saying we're going to do the transition, and then they're going to, so here they'll say, the first option was transition by S3. Well, that's not going to work, because if I do that, remembering that this is assumed a 1, 3 and 1, 3 plus 1, that only gives 4, and I want 5. So then if you look at this scenario, they're saying the transition to the power of 2 times S3. Well, this is going to work because this number plus this number gives 5, and that's what we want, so state 5. So that's the answer to that question.